This is lesson 91 in Saxon's 3rd edition, Algebra 1. This lesson is on the multiplicative property of inequality and on spheres and how to find volume and surface area of a sphere. So two very different things. Let's take a multiplicative property of inequality first. So in both equations and inequalities, we know that it's true that you can add the same number to both sides without changing the solution. And you can also multiply on both sides with by the same number. But there is one exception to that. If you multiply by a negative number in an inequality, it changes everything. In an equation, it does not change. But in an inequality, it does change everything. So let's look at why that's true. So if we say 5 equals 2 plus 3, that's a true statement. And 2 plus 5 equals 2 plus 2 plus 3. So if I add 2 to the left side of the equation and add 2 to the right side of the equation, I still have a true answer, 7 on both sides. All right, in an equation again, 5 times negative 2, and then 2 times negative 2 plus 3 times negative 2. Well, we've got, if we had 5 equals 5, let's say to start with there, and because 5 equals 2 plus 3, and we know it does. And then we're going to multiply every number by negative 2. So we say 5 times negative 2 is negative 10. 2 times negative 2 plus 3 times negative 2, we have negative 4 plus negative 6. That also is a true statement. However, and that's in an equation, but look what happens when you have an inequality. 8 is greater than 5, that's a true statement. If I multiply both sides by a negative number, let's say negative 2, 8 times negative 2 is negative 16, and 5 times negative 2 is negative 10. Now it is a false statement because negative 16 is not greater than negative 10. So this is the premise that we're going to be going on when we start doing these graphs of these negative inequalities. Okay, let's see how we would graph this first example. It says graph the solution, negative x is greater than or equal to 2, and our domain will be real numbers when we graph. Okay, so negative x is greater than or equal to 2. I'm sorry. If we multiply both sides by negative 1, I'm sorry, then we kind of get rid of that negative in front of the x, which that's our goal. We can't have a negative x. We need a positive x. So now we have to say x is less than or equal to negative 2. If it was greater than or equal to 2, it is less than or equal to negative 2. So the rule is we're going to flip the inequality sign, the greater than or less than sign, when multiplying by a negative number. That'll be the rule. So this new sign is what we're going to actually graph. X is less than or equal to negative 2. So because it contains the line that means equal to, we're going to start on negative 2. We're going to do a closed circle because it includes negative 2. And then we're going to go left because x is less than negative 2. This example says graph the solution 4 minus x is less than or equal to 6. And in this example, our domain is going to be integers. All right, so first we're going to isolate this negative x by moving this 4. And the way we do that is to subtract. We have a positive 4, so we'll need a negative 4. Now we've got rid of that, and we have negative x is less than or equal to 2. Now, if we multiply both sides by a negative 1, or, I'm sorry, multiply both sides by negative 1 to reverse the inequality symbol, we would then have x is greater than or equal to negative 2. See how you just flip things around? Remember, you're going to move, let me show you. You're going to move this negative over here, and then you're going to flip this inequality sign. Now, how do we graph that? X, and our domain is integers. You've got to pay attention to your domain or that can make everything wrong. X is greater than or equal to negative 2. All right, if it is equal to, it begins at and includes negative 2. The next integer after negative 2 is negative 1. And the next integer is 0 and 1 and 2, 3, 4, 5, and so on. Now, if my domain was real numbers, I would have started here at negative 2 with a closed circle, and I would have had an arrow, a line with an arrow going right. All right, example 3 says graph the solution to negative 3x plus 4 is less than or equal to 13. In this one, our domain is real numbers, so we're going to have a line and not the little dots. So the first thing we're going to do here, just like if we were solving an equation, we're going to subtract 4 from both sides. So we have negative 3x is less than or equal to 9. And then we are going to multiply by both sides by negative 1/3. And we get rid of this negative here. We've made x positive. We got rid of the 3. We got rid of the negative sign. X. Now we have to flip the inequality. And now the 9 is going to be negative, and it's going to be negative 3. Because this would be 9 over 1 times 1 over 3, which is 9 over 3, which reduces to 3. All right, so x is, this is what we're going to graph. X is greater than or equal to negative 3. If it is greater than or equal to, I'm going to shade in the circle, and then I'm going to draw my line, and I'm going to put the arrow that it's going to continue going. Okay, let's talk about spheres now. Okay, when I think of a sphere, I think of a basketball, typically. And when you're finding volume of a volume of a sphere is exactly 2/3 times the volume of the smallest right circular cylinder into which the sphere fits. So if I could imagine a can, which is a right circular cylinder, that was big enough around and tall enough to hold a basketball, then the way I could figure the volume of that is to find the volume of the cylinder, which in a right circular cylinder I have to find the area of the base, which is pi r squared, and then I say that 2 for the volume. I say in this particular one I would say 2r, because that is my height. So 2r times pi r squared equals 2 pi r cubed. Now, the volume of the sphere inside, that is the volume of the can, okay, the circular cylinder. The volume of the sphere, obviously, when you look at it, you can see it doesn't take up as much volume as the can itself. So we say it takes up 2/3, like there's a little bit left on the bottom and a little bit left on the top. So it takes up 2/3 of the cylinder. And if if the volume of the cylinder was 2 pi r cubed, then we would say 2/3 times 2 pi r cubed equals 4 pi r cubed. 4/3. 4/3, because 2/3 times 2 is 4/3. And so that's how you get that. So if you close your eyes and try to remember the diagram of the basketball inside the can, it's going to help you to remember the formula for volume of a sphere. We don't really do proofs in this book, but proofs is more of a geometry thing. But there is a proof that we can see that this is actually a true statement. And we can attribute that to the Greek philosopher Archimedes. Okay, so let's move on and talk about how to find the surface area of a sphere. There's an easy way to remember also how to find surface area of a sphere. The surface area equals the sum of the areas of 4 circles, each having the same radius as the sphere itself did. Alright, so you've got the sphere, which is a three-dimensional object, and then you've got 4 flat circles, okay? 1 plus 2 plus 3 plus 4. So if you could think of this as being side 1, side 2, side 3, and side 4, okay, of the sphere, they all have the same radius. So you would just say 4 times pi r squared. So you take the formula for area of a circle, pi times radius squared, and then multiply that by 4 if you have a sphere. All right, let's work some practice problems. All right, this one says, find the volume of a sphere whose radius is 3 centimeters. All right, well, if we know that we're looking for volume, so our formula is 4/3 times pi r cubed. Then we're going to say if our radius is 3, then we're going to say 4/3 times pi times 3 3 cubed. And I know that 3 cubed is 27. And 27, I'm going to say 27 times 3.14 times 4. And then I'm going to divide that all by 3 because of 4/3. Okay? And my answer when I do all that on my calculator will be 113.04 centimeters cubed because it's volume. Alright, this says find the surface area where of a sphere whose radius is 4 meters. Alright, my surface area is formula is 4 times pi times the radius squared. So I'm going to put in 4 right here for r. 4 squared is 16 times 3.14 times 4. And when I do all of that on my calculator, I'm going to come out with 200.96 meters squared, because remember, area is always squared. Okay, so let's go ahead and do our practice problems for this lesson. Graph on a number line, negative x is greater than or equal to 5, and our domain is real numbers. All right, so we're going to have to multiply both sides by -1 times -x is greater than or equal to 5 times -1. And here I've gotten rid of my negatives, made it positive. X, I'm going to flip this, is less than or equal to, and now my 5 is going to become negative. X is less than or equal to -5, and I'm going to put, because it's equal to, I'm going to put a dot right there, and then my line with my arrow going to the left. Should have made my number line a little bit longer on the negative side, shouldn't I? But anyway, that's what it would be. This says graph on a number line 2 minus x is not less than or equal to 1. The domain is integers. All right, well, first of all, we have a negated inequality. So let's turn it around. 2 minus x is greater than 1. Remember the trichotomy axiom? If it is not less than and it's not equal to, then it has to be greater than. All right, so we're going to isolate the x over here by subtracting 2 on both sides. And I have negative x is greater than -1. And then when I multiply both sides by -1, -1, I'm going to get rid of this negative sign, and it's just going to be x. I'm going to flip this, and I'm going to have -1 times -1 is +1. So x is less than 1. It does not include 1, so I'm going to have an open circle. Oops, I'm sorry. I was not paying attention to my domain. If my domain had been reals, that would have been correct. But my domain is integers. Now, it does not include 1, so I can't start at 1. My first integer that would be less than 1 would be 0, then -1, then -2, -3, -4, and so on. So that one has several steps that I have to do. You have to be really careful. Every step is an opportunity for a careless mistake, just like I almost made there. Okay, C says graph on a number line, -3x plus 5 is greater than 1. Our domain, again, is integers. And I'm just going to wait and draw my number line here in a minute. So let's subtract 5 from both sides. And I have -3x is greater than -4. And then if I multiply both sides by -1/3, so it is going to be +4/3, or which we know is 1 1/3 for graphing purposes. Now remember that I said that our domain is integers. Well, 1 1/3 is certainly not an integer. So let's start here with 3, 2, 1, 0, -1, -2, -3, -4, and so on. All right, the first integer that is less than 1 1/3 is +1. Then 0, then -1, and -2, -3, -4, and so on. Okay, let's do our next one. Find the volume of a sphere whose radius is 4 inches. All right, our formula for volume of a sphere is 4/3 pi times the radius cubed. All right, if I put in 4 for the radius, 4 cubed is equal to 64. And if I use my calculator and I say 4/3 times pi times 64, or I could say 4 times 64 times pi and then divide all of that by 3. When I do that, I would get a total of, let's see, 4 times 64 is 256 times 3.14 divided by 3 is equal to 267.95 inches cubed because it's volume.